Hi, everyone. In this lesson, we will learn concrete resistivity inspection and evaluation. In daily life, we observe that most of the wires around us are copper wires because it is a good conductor. Low resistivity. We can use it to long-distance power transmission. Meanwhile, we also have equipment for insulator that blocks current. Its resistivity is very high. Therefore, we can detect the resistivity of concrete to evaluate its conductivity. The task mainly explains the following four contents. 1. Method for concrete resistivity inspection. 2. Concrete resistivity testing instruments and technical requirements. 3. Measurement of concrete resistivity. 4. Evaluation standard for concrete resistivity. The resistivity of concrete reflects its conductivity. If rebar corrosion occurs, high concrete resistivity, then the development speed is slow. Weak diffusion ability. The concrete resistivity is low. Corrosion development speed is fast. Strong diffusion ability. Therefore, measuring the resistivity of concrete is an important aspect of the inspection and evaluation of rebar condition. Concrete resistivity. The 4-electrode impedance measurement method can be adopted, even if the concrete surface contacts 4 electrodes at equal spacing. The 2 outer electrodes are current electrodes. The 2 inner electrodes are voltage electrodes. By detecting the concrete impedance between the 2 voltage electrodes, obtain the concrete resistivity ρ. As shown in the figure, the resistivity tester consists of a 4-electrode probe and a resistivity meter. The 4-electrode spacing of the probe is adjustable. Adjustment range 10 centimeters. Each electrode is equipped with a pressure spring, thus ensuring the measurement of resistivity at different depths, and the electrodes should have good contact with the concrete surface. Here, we need to pay attention. Input impedance between voltage electrodes 1 megohm. The diameter of the electrode tip must not exceed 5 millimeters. Display method. Digital display of resistivity value. Power supply is required. DC supply. Continuous normal operation time, not less than 6H. The instrument's operating ambient temperature is 0 to 40 degrees Celsius. Relative humidity is less than or equal to 85%. The concrete resistivity tester must pass technical certification with a product qualification certificate and conduct regular metrological standard verification. Resistivity measurement. Measurement area and position arrangement. Refer to the requirements for reinforcement corrosion potential measurement. Conducted between potential measurement grids. And complete the numbering work. The concrete surface should be clean, dust-free, free of grease. To improve measurement accuracy, remove the surface carbonation layer if necessary. Adjust the spacing of the instrument electrodes. The generally adopted spacing is 50 millimeters. To ensure good and continuous electrical contact between the electrodes and the concrete surface, apply coupling agent to the front end of the electrodes, especially when the readings are unstable. During measurement, the probe should be placed vertically on the concrete surface. Apply appropriate pressure. Based on the measured resistivity value, we can refer to the resistivity evaluation standard in the table to determine the possible corrosion rate of the rebar. thereby determining its evaluation scale. When the resistivity is greater than or equal to 20,000 ohms, centimeters, the possible corrosion rate of the rebar is very slow. Evaluation scale is 1. Through the learning of key points in this task, it is hoped that you will understand in the future technical requirements for the concrete resistance tester. By calculating the resistivity value, evaluate the potential corrosion rate of the rebar. Preliminary learning. We categorized and taught non-destructive testing methods for detecting activation level of steel reinforcement in concrete. Please remember these 4 methods, respectively: the reinforcement corrosion potential, chloride ion content in concrete, concrete carbonation depth, concrete resistivity, among which the test results of reinforcement corrosion potential. It serves as the basis of measurement area selection for the other 3 corrosion detection methods.